Right, so good morning everyone and welcome to day 2 of Love Data Week. Delighted to have Stephanie and our colleagues with us this morning to present on Train AI for Love Data Week. I will let you all do your own introductions and without further ado, hand on over to you, Stephanie. Thank you.
Many thanks. Great, Fiona, and thanks for allowing us to participate. I guess what you'll see is a long list of the team members on the Train AI project. The principal investigators for Train AI are Tim McCarthy and Rowan Feely. And there's an even bigger team than what's shown here, but we're largely just mentioning the team to do with a lot of the data components and the data side of the Train AI project. So we have Dr. Paul Lewis, who looks after our data platform, so the architecture. We have Dara Walsh, who's he's going to be presenting towards the end of this, so he's online here. We have Dr. Gaurav Mirza, Liam O'Sullivan, myself, Stephanie Kyo, Palave Prasad, Samuel Bosi, and we have Brian Caulfield, who's another co-PI on Train AI. So they're the main kind of team members carrying out the work that you'll see today as part of Train AI. Let me know now if my slides are moving through. So just to give you a brief summary of what we hope to cover today. So we'll start off, we'll give you a little introduction. We've got quite a nice video that helps to explain some of the kind of the rationale behind the project. We're going to talk about our data platform and how we've generated a data catalog to support that platform. We'll show you our data dashboard. So how do we visualize it? And we'll give you quite a real world example of the kinds of things that the platform is enabling our researchers to do. And so that's the Urban Driveways project. Then we'll move on to what's called Jupyter Notebooks. So this is again another practical example of how researchers might use their data sets in quite an open, transparent way using open source tools. So Dara has kindly agreed to demo both our kind of data dashboard, looking at some examples, and also to give you an idea of how to use Jupyter Notebooks. And after that, we're more than happy to take any questions. So I'll just move forward here and I'll just bring the video into the screen. So if there's any issues with viewing this, you might just let me know. We should be able to view it quite easily. And let me know also with the sound. So use the chat. People can hear it. Great.
Train AI is fundamentally about developing new standards around the measurement, monitoring, verification, and reporting of carbon stock emissions across complex terrestrial environments.
We're looking at all of these natural environments, agriculture, forestry, and peatlands. And we're looking at how humans interact and manage those.
If you know where the emission is coming from, you can now deliver a spatially refined policy focused on that specific source or location.
The training data that we're bringing together for Train AI is quite unique. There's no other research project that's really brought so much environmental data about the world around us together.
There's a lot of multi-thematic data sets involved, from spaceborne sensors right down to in situ sensors, and it's of petabyte scale. So we've got a high volume of data coming through.
How do we take that information and extract the maximum information we can from that data and even generate new information around human activities? This is essential because it's the human activity that drives the emission off the landscape.
We need to not only be able to measure these greenhouse gas emissions, but also communicate that with the end users. So these are the national representative groups like farming associations, landowners and foresters.
Once we get to that really accurate level of carbon measurement, farmers can ultimately become carbon traders themselves. The carbon sequestration that they're doing on their own land, they should be able to trade that on global carbon markets. We've got the opportunity, obviously, as a global company like Microsoft, to really help scale the solutions out globally.
If we can produce more reliable and more accurate estimates of carbon stocks and emissions across the landscape, we provide the scientific evidence base to inform much more refined policy that can deliver a measurable reduction in carbon emissions.
Now, so we'll just move on from that, but essentially, I guess from that short video, you may have gotten from that this is essentially about climate change, it's about carbon measurements, the rationale behind it being that we need to reduce our global carbon emissions by half by 2050. And we need to come up with solutions to support our measurement and verification of carbon reductions. So again, you'll have seen that, you know, it's really about using data sets from a broad variety of sensors, whether that is from spaceborne satellites, whether that is from in situ networks. So these observation or monitoring stations on the ground measuring emissions of CO2, but also looking at things like soil moisture. We also collect, as you'll have seen from the video, data from aerial, so aircraft, so Cessnas, and also from various different drone platforms. And again, these all are carrying very sophisticated sensors on board and are able to collect large areas, data from large areas across different terrain types in Ireland to begin with. But as you'll have seen from the video, you know, we're really working towards how do you scale this solution to other EU member states and even further afield. What do we do with all of that data? And you'll see it's really about the complicated part is really about trying to fuse and integrate and collate all of these data sets in one place so that we can easily visualize them, we can easily analyze them, and we can basically support decision making. And it's about integrating different Earth system models, informing users and landowners, whether that is a forester, whether that's an urban or a city planner, or whether that's a farmer. And all the while, it's really the overall aim is this sustainable living and sustainable planet. I won't dwell too much on this slide because it goes into quite a bit of detail, but again, just going through the drivers for us and the rationale is really emissions reductions, sustainable living, reducing some of the uncertainty that is currently out there around, well, how do we, if we can't measure carbon effectively, how do we know we're actually reducing our emissions? And, you know, so the outputs of that is really verification of carbon reductions, maybe improving standards and methodologies, and again, working towards a more sustainable planet and a greener economy. The project itself, you will have seen, is funded through SFI and Microsoft Ireland. Maynooth University are the lead research partner. There's a team of 50 people on this project, and you'll see this from the next slide. You know, the broad number of stakeholders, including other higher education institutes. So you'll see we have Maynooth obviously on board, but we're working very closely with DCU, with Teagasc, with Trinity, UCD and Limerick. And I guess in order to make sure that this platform is co-created, we have a number of different partners from industry, from associations, community groups, from European agencies, and also from government departments within Ireland. We have to remain aligned to current policy and how we can support policymakers. This is just a schematic. I guess when we talk about different terrain types and various different data sets, this is just a nice way to visualize what we mean by these different terrain types, and what kind of data will be coming off each of these terrain types, and how would we collect that. So as we said, there might be in situ or monitoring stations or flux towers. There's satellite imagery. There's also imagery that is being collected from farm machinery. And we're working with some agricultural industry partners with that data at the moment. So again, a schematic to show that essentially from all these terrain types, the data is filtered up into a kind of a computational data platform. And from then on, we'll work on a series of different projects with the 50 researchers that we have on board, with various, we'd say, expertise, looking at forestry, grasslands, urban, and so on. Just to give you a little bit of a background on our data platform and our data catalogue, there's quite a sophisticated architecture in the back end of this, but unless people want to know more, we're more than happy to talk to people about that architecture. But for the moment, we just wanted to keep it an audience that would be more general and to keep, I guess, the interest there. But essentially, it really is about developing cloud-based approaches. So where traditionally people would have downloaded data to their own desktops, these data sets might be, as we said, gigabytes moving into terabyte scale and working offline in their own software packages and visualizing, analyzing offline. Really, we're trying to move things to the cloud where you can do things quite seamlessly. You can use data, it's analysis ready data, and it just improves those automated workflows and being able to enable a researcher without maybe a lot of machine learning expertise to be able to start to work in and do new kinds of analyses. So looking at the data catalogue, really the objective was, and as you'll have seen from previous slides, there's a vast array of data. So the objective of the data catalogue was really for rapid data discovery. So not only have we 50 researchers working on the project, we have different stakeholders that might want to access that data and access the dashboard. So really we need something quite simplistic, but something that you can rapidly see what data is available and evaluate whether that is actually fit for your intended use. So within the data catalogue, you're able to see the spatial and the temporal extent of a data set, what type, what file format, and as much as possible, we would always work with open file formats. So these are things that you don't actually need a proprietary software to work with. And second of all, what the data catalogue really allows us to do is identify data stewardship and governance and data management practices. So for each data set, a user will be able to see who's published this data set, who knows a lot about it, and who can I contact if I want to know more information, or if I have any questions about any pre-processing steps, for example. What you'll see is a high-level description of that spaceborne satellite data moving down into the airborne, the UAV, and the in situ on the ground. So we'll have, you'll see lists of different data sets. We've thousands on the data catalogue. So this is just giving you a high-level idea of what's on that catalogue. And you'll see number 5 is GIS. So this is just Geographical Information System type data. And ultimately, and what's important, especially with Love Data Week in mind, is we are actually reusing a lot of open data from various different Irish data suppliers, and you'll see a list of them coming up shortly. And typically these data sets are in GeoJSON formats or CSV formats. So again, following that open data standards. Here's a quick look at what that data catalogue looks like. So we can see that we're able to filter our search results by different data types. So as a researcher, am I interested in satellite data? Am I interested in observational data captured at the ground from observation stations? Am I interested in drone data? Do I need a closer look than maybe what a satellite can provide? So you'll see where we have a list of satellite data there. You'll be able to see the timestamp that relates to that data set in particular, and you'll see a little bit of information about each of those data types. Moving down into some of the airborne and aerial data sets, as I told you, this is collected, and you'll see this is a bespoke sensor pod where we would mount things like multispectral cameras. That gives us multispectral information, so that can tell us a little bit about phenology and crop health. We've other things like high resolution cameras that give us a little bit higher resolution than, let's say, what a satellite imagery might provide for us. And that's important because, as Dara will highlight to you later on, satellite information is great for large portions of the Earth, but when you have a high cloud cover like Ireland, it means that a lot of the time when a satellite does overpass Ireland, you actually won't get cloud-free information. So that's why we help supplement the satellite data for Ireland with some airborne aerial information. Moving again a layer lower to the surface, we look at UAV and drone-derived information. And we're lucky that we have a drone operations team that help us to coordinate these different flights over different terrain types. And again, looking at, very, very sophisticated instrumentation that are mounted to these drones, and things, again, looking at multispectral sensors, hyperspectral sensors, things like LiDAR. So giving us a 3D depiction of a site can be very important for different reasons. The in situ, this is just to give you an idea of some of the in situ observation stations that we have in Terrain AI. So really it's trying to marry the data from different layers with the data coming from these ground stations. And things that are measured are like CO2, we have latent heat, water flux, and we also have CH4, so that's methane. So again, a very important greenhouse gas, especially in terms of agriculture. We also have soil chambers and soil moisture probes. We have phenocams. So a phenocam is essentially a camera that can look at a crop and it's able to gauge the phenology and how that crop is growing throughout a season. And also a lot of the time co-located to these sophisticated measuring stations are things that measure simple climate variables. So you'd be looking at precipitation, humidity, wind direction, and wind speed. I touched on this a little bit earlier. This is the GIS data sets that we have on the dashboard. And just to kind of reiterate that we're working with nearly over 30 different data providers from across Ireland and Europe, and we're reusing their open data. So that might be data from the Central Statistics Office, from Met Éireann, Dublin City Council, Cuilcha, Teagasc, the Office of Public Works, the Department of Food, Agriculture, Food and Marine, the Environmental Protection Agency, Ordnance Survey Ireland, Transport Infrastructure Ireland, and the National Parks and Wildlife Service. So that's only some of them, but it's to give you an idea that a lot of this data is openly available online through various different open data portals. So if you are a researcher, or if you're studying to do an undergraduate thesis or a postgraduate thesis, and any of your your research questions, it might be aligned to geospatial work, it might be aligned to population statistics. There is a lot of data openly available, and this is published and very easy for you to download and work with yourself. Again, what's really important, we have so much data, but metadata is essentially information about a particular data set. And that's really important for us to collect, because if you are a researcher, you want to know a little bit about where that data set was sourced from. You want to know things about the data set type. So what file type is it? Where is it located? What resource language is it in? What is the topic or the topic category? What are some of the keywords? The geographic bounding box simply relates to where on the earth is this data set referring to. So the temporal reference, again, looking at a timestamp. So what time frame is this data related to? Looking at lineage, so this is really important. This is about the overall quality of the data set, describing its pre-processing steps and how it got to this stage that it's at the moment. So these are a list of some of the metadata descriptors that we use, and these are closely aligned with the INSPIRE data standards. So INSPIRE, if you were to look that up, is an EU-driven set of standards for geospatial information. So again, we have to make sure that if we are creating and collecting data, that we are following the best practice and best practice standards, and that we are linking in with existing frameworks. So INSPIRE is one of that. Just to give you another look at the data catalogue, this is going into more information. So really showcasing, this is our metadata table. These are the things we describe, and this is what it looks like to a user, where you'd see the title, you'd have a little bit of information in the abstract, the resource type, a topic category, looking at some of the processing steps, the resource language, so what file types, some keywords, the exact link to actually download that data for yourself, spatial resolutions, temporal, conditions for use, so if it's an open Creative Commons license that anyone can use, the responsible organization, and what's really important is this metadata point of contact. So being able to see Who do I email if I have further questions that aren't in this metadata card, if you like? So being able to pick up the phone or email somebody can be really important as a researcher. Again, you'll see this is a very complicated set of variables, but when we think about going back to those stations that are on the ground, they collect a whole host of variables, and they need to be organized, collected, and documented in a way that researchers are very easily and seamlessly able to work through it. So they understand the data in each different column, if that's the way it's organized. So all of these things you can imagine take a lot of time with a small enough data management team. But we're working through the data sets, and we're providing templates and creating best standards. The Geospatial Dashboard, again, is what we mentioned. How do we visualize all of this data in quite an intuitive and a user-friendly way? So it's for end users. It's a window. It's a graphical user interface. It allows people to form maps of their own, using different data layers and focusing on an area of interest. And it also looks at those benchmark or those on-the-ground stations, if you like. And it allows users to create projects based on an area of interest, as I said, and pull in different data that is available for that area of interest. So what does that ultimately look like? Well, just to give you a flavour of what that data platform looks like, and again, Dara will work through this in the next few minutes. This is one site that you'll see on the left-hand side. We've a map with various different benchmark sites located on them. So these are all with kind of ground stations, and we've gone in and we've actually flown drones and aerial aircraft over these locations to gather more information. And this is essentially kind of what it might look like, where you have satellite information, drone information, and all layered. If you see that layers control button, people being able to turn on and off layers and do quite straightforward analysis here. To give you, I guess, a better sense of some projects, you'd say, well, what's all this for? We have various different projects across our research teams. And one of them is an urban driveways project, which I'll go into in a little bit more detail. But this is just giving you, I guess, a look when we talk about data platforms and data dashboards. This is ultimately what we're talking about: going in, a user interface, a point and click, being able to model, analyze. And I guess if we look at the urban driveways project, just to give you some rationale and some context there, only in September of 2021, our own government set out a pathway to reach, well, it sets out ambitious targets, which is to roll out 180,000 electric vehicles by 2025, which is very soon, and to increase this to almost 1 million by 2030. And we would say, well, a practical problem, let's say, with the rollout of electrical vehicles is that they need to be plugged in, and largely they'll need to be plugged in your driveway. Plenty of people don't have driveways. And if they do, and if they have to park off street, you can't have that cable going across a footpath. So in the first instance, one of our projects, we said, well, let's see how we can help to identify who has driveways and to understand, well, who would be able to plug in if they were given, let's say, whether it's grants or other incentives, who could, in the next, over of course, a short period, implement and have an electrical vehicle charger put in their own driveway. So we needed to identify where these driveways are. And that might sound like quite a simplistic kind of research question, but I guess ultimately what you'll find is we'll go through a couple of steps to show you some of the difficulties around that, and also how is our data platform enabling researchers to come up with information that's relevant to policymakers. Now what I want to kind of introduce you to is Jupyter Notebooks. And as I said, Dara's going to talk about this in more detail, and I'm going to pass him over in a few minutes now to do the demonstration of the data platform and a demonstration of Jupyter Notebooks. But just to give a little bit of background, and this will be relevant to possibly more for postgraduates or people looking to go into more data analysis type roles. But I guess Project Jupiter, it's a project and a community whose goal is to develop open source software, open standards and services for interactive commuting. So you can work across a range of languages that you're comfortable in, whether that's R or Python. You can share notebooks, so you can share your own code. And that can be really useful for people starting off in code. They'll be able to take a look at what's already up there on the Jupyter Notebook viewer, share what they're doing, ask for help, load things onto GitHub, have a GitHub account. And really what that does, it helps you keep a record of your own code, which can be really, really useful, particularly if you're writing, let's say, a PhD thesis. There's interactive output, so you can output your visualizations, you can output into videos and other different data formats. But I guess what's really going to help is for you to actually see this in action. So what I'll do now is I'm going to hand over, Dara's going to do the data platform demo and then follow on with a Jupyter Notebooks demo. And then we'll close off with a couple of questions in the next few minutes. So I'll stop sharing, Dara, and if you're happy to take over.
Yep. So just give me a second. Just let me know when you can see the screen.
Yeah, I can see it here.
Okay, so what I'm showing here is the data platform. So this is for just an overview of how the system works. So as you can see here, we have a mapping interface and we have a number of sites around the country. So if I zoom in here, we can come to look at one of our sites. So we're looking at Castle Tropical Grasslands. So what the first thing you're seeing here is what's known as a NDVI. So that's a normalized difference vegetation index. So it's drone-derived data using multispectral data. And what this gives us is an idea of the crop health. So it lets you know how healthy crops is. And what we can do is we actually have a time slider here, and we can then come through the dates and see how stuff changes through. Now, another thing we can do with this online platform is we can start uploading data like the lipids data set. So we can come in here and we see the field boundaries, and we can actually see what type of crop is being grown in a certain field. And then another thing we can do is we can also bring in some more of the airborne data we have. So we've shown the drone data there, but we can also, across different dates, we can also bring in data from spaceborne. So what I'm going to show here now is Sentinel-2 data. So Sentinel-2 is a satellite that is a part of the Copernicus program. The Copernicus program is the European Union's Earth observation program, and it aims to achieve a global, continuous, autonomous and high quality, wide range Earth observation mapping program. So what I can do here is, if I just scroll down slightly, I can start to load up some of the RGB data. So as you can see, it's quite a large area covered off. And if I just bring up info, sorry. So I'm just going to actually bring it up slightly different ones. I'm going to bring up this one. So I'm going to bring up what's known as true color. So the problem with Ireland is we have a lot of cloud, and there's nothing we can do about that. So due to having lots of cloud, it's very useful to have drones and light aircraft flying and taking data for us. But we can't have the drones and the aircraft out every day because it's just not practical. But with Sentinel-2, we're having a 5-day visit. So that means there's a twin pair of satellites. They're about 1,100 kilos each, orbiting the Earth at 786 kilometers altitude. And they're doing about 14 revolutions of the Earth every day. But with this twin pairs of satellites, we're getting revisit times of every 5 days for the same part of the Earth. So we're getting snapshots of the Earth up to 10-meter resolution every 5 days. But as I said, cloud is an issue in Ireland. But with this data platform, what I can actually do is I can come in here and I can say what's the maximum amount of cloud cover is acceptable, and I can do a start and end date. Now the benefit here is if I just drop down to cloud cover, this is now going to go and load the latest cloud-free pixel, and if I go update layer, now we have a cloud-free image. And if I change the dates to be a bit stricter, maybe let's change here. Now you update layer again. Okay, so what we're seeing here was there was relatively recently cloud-free image. This lets people come in and start looking at Earth observation data, so satellite data, and they can, because of cloud, we can just set a date range in the maximum cloud cover. And not all the time here, we're lucky we're getting a single image, but sometimes you'll have a kind of patchwork map of the land we're looking at. And that means we can get up-to-date information about what's on the ground. We can also do a vegetation index as well with this. So greener colors will, darker green indicate healthier vegetation. This is all at 10-meter resolution, but it means we can have a look at, we have a high revisit time, and if we're lucky, we get a good few observations throughout the year. So this would be for the average day user to come in and start looking at data. But what we also have built on top of this is the Jupyter notebooks. So as Stephanie mentioned, Jupyter notebooks are a collaborative way of working. So with these Jupyter notebooks, we've built what's known as a data cube. So normally when you work with satellite data, you have to download gigabytes and gigabytes of data, analyze it, check if it's cloud free, crop your data, and then get your data in what's known as an analysis ready data set. With the benefit of with the data cube we've developed, is the data's already in analysis ready data, and we actually store it in a format that's called COG. So COG stands for Cloud Optimized GeoTIFF. A GeoTIFF is just an image with every pixel will normally have an RGB value, so red, green, blue. It will also have a coordinate associated with it, so we can map it. So the benefit of using these Jupyter notebooks is it's an online based system. People can log in, you don't need a really powerful computer, and you can start to look at gigabytes of satellite data quickly and easily. So here's an example. I've defined an area. This is Oak Park, just beside Carlow. And what I can do is I can come in and say, I want to load Sentinel-2 data. I give the date range, and very quickly pull out data that's ready to work with. Now, I have set a cloud cover percentage. So I said the minimum good data is 90% cloud free, but not every cloud detection algorithm is perfect. So what we can do is we can come in, visualize, and then drop off some of the data sets that aren't perfect. But normally where this could be hours of work, you can actually do in a couple of minutes. And then we can start to look at building up time lapses, as well as looking at NDVIs, as I mentioned before. And then we can start to look at things like change detection, what's happening throughout the year, as well as we can look at plot and index of the vegetation over time. So we can see 2 drop-offs, and that's probably when the fields are plowed or what else is happening. And other things we can do with is, another example of what to do is, so here in Maynooth. So recently in Maynooth, there's been a large estate build called Maria Villa up here. So what we can do is look at urban change detection. So these are a number of images. As you can see here, it's completely free, but as time goes on, we can see the estates being built. So what we can do is come in here and do urban change detection, and we see we're getting change detection up around here. And as a final example, I can also show we can monitor things like chlorophyll A in a lake. So I have defined an area of interest here. I can go pull all the cloud-free data over time. We can have a look at how it changes over the dates. But what we can do is start to look at mapping information about the lake. So what we can actually do here's a simple example where this line here is showing lake water level. So what we use the Sentinel data is to estimate the coverage in kilometers squared of the lake. So as the water level rises, the area that the lake covers will rise. And we can also look at the indication of how much chlorophyll we're seeing in the lake, and we see the higher level is shown as a more yellow color. So there are just some examples, but again, is the benefit of the data platform, which we see here, is it makes it very easy for a user who might have a background in geospatial to come in and get data easily and interactively and intuitively. And then with a more experienced user, they can come in and use the Jupyter notebooks where they can collaboratively share their methodology. As you can see, there's text talking you through it, but they can use this to share their methodology, share code, and access petabytes of data in a very efficient manner to process data and get insights into what's going on the ground.
Thank you, Dara. And
I'll just stop sharing.
I just had one more slide, and it was literally a thank you slide, and to kind of close off by saying, like, if people have questions or any insights or any comments, we'd be really interested to hear.
Thanks so much, Stephanie and Darren. That was absolutely fascinating. I mean, it's combined so many critical things there, from climate change to open data and research, data management. It was really, really fascinating.